Hello everyone, this is Shruti. My roll number is 234G180139. I am studying first civil engineering in SRIT college. Subject name is Engineering Mechanics. Introduction to polar moment of inertia. The polar moment of inertia is a measure of an object's resistance to torsional deformation. It quantifies how the object's mass is distributed around its rotational axis. Polar moment of inertia is crucial in determining the strength and stability of structures under torsional loads. Calculating polar moment of inertia. To calculate the polar moment of inertia for a simple geometric shape, you typically need to integrate the mass distribution around the axis of rotation. For more complex shapes, you can use standard formulas or software tools to determine the polar moment of inertia. Polar moment of inertia is an essential parameter in engineering design, especially in the analysis of shafts, beams, and other rotating structures. Determine the moment of inertia shown in the figure about an axis passing through centroid and parallel to the topmost fiber of the section. Also determine moment of inertia about the axis of symmetry, hence determine the radii of gyration. Area A1 equals to 150 into 10 equals to 1500 millimeter square. A2 equals to 140 into 10 equals to 1400 millimeter square. Total area equals to A1 plus A2, that equals to 1500 plus 1400, that equals to 2900 millimeter square. Y1 equals to 10 by 2 equals to 5. Y2 equals to 10 plus 140 by 2 equals to 80. Y bar equals to A1 Y1 plus A2 Y2 by A1 plus A2, that equals to 1500 into 5 plus 1400 into 80 by 1500 plus 1400, that equals to 41.21 millimeters. G1 equals to Y minus Y1, 41.21 minus 5, that equals to 36.21 millimeters. G2 equals to Y2 minus Y, that equals to 80 minus 41.21, that equals to 38.79 millimeters. I according to x-axis, that equals to bd cube by 12 plus a1 g1 square plus bd cube by 12 into a2 g2 square, that equals to 150 into 10 150 into 10 cube by 12 plus 150 into 36.21 whole square plus 10 into 140 whole cube by 12 plus 1400 into 38.79 whole square. I according to x-axis, that equals to 37224 millimeter per 4. Similarly, I along y-axis equals to Ig1 plus Ig2, that equals to 10 into 150 cube by 12 plus 140 into 10 cube by 12, that equals to 2824166.7 millimeter per 4. K equals to root of I by A. K along x-axis equals to root of I along x-axis by A, that equals to root of 6372242.5 by 2900, that equals to 46.8763 millimeter. K along y-axis, that equals to root of I along y-axis by A, that equals to root of 2824166.7 by 2900, that equals to 31.21 millimeters. Define angular velocity. Angular velocity is the rate at which an object rotates around a specific axis. It is measured in radians per second or degrees per second. Angular velocity can be calculated by dividing the change in angle by the time taken to make that change. A man weighing 637 newtons drives into a swimming pool from a tower of height 19.6 meters. He was found to go down in water by 2 meters and then started rising. Find the average resistance of water, neglect the resistance of air. Given that weight equals to 637 newtons, height equals to 19.6 meters, distance equals to 2 meters, g that equals to 19.8 meter per second square. Let Fr equals to average resistance. Initial velocity of man u equals to 0. V square equals to u square plus 2gh. That equals to 0 plus 2 into 19.8 into 19.6. V equals to 19.6 meter per second. That is taken as equation 1. Now distance travelled in water equals to 2 meters. V equals to 0. U equals to 19.6 meter per second. Now apply. V square equals to u square minus 2as. 0 equals to 19.62 minus 2a into 2. A equals to 96.04 meter per second square. That is taken as equation 2. Since net force acting on the man in upward direction equals to Fr minus W, but the net force acting on the man must be equal to the product of mass and retardation. Fr minus W equals to Ma. Fr minus 637 equals to 637 by G into 96.04. Fr equals to 6879.6 newtons. Understanding the work energy equation for translation. The work energy equation for translation states that the work done on an object is equal to the change in its kinetic energy. Mathematically, this can be represented as W equals to delta Ke, where W is the work done on the object and delta K is the change in its kinetic energy. In simpler terms, when a force is applied to an object and causes it to move, the work done by that force results in a change in the object's kinetic energy. Two blocks of weight W1 and W2 are connected by inextensible wire passing over a smooth pulley as in the figure. If W1 is greater than W2, find the tension in the string and the acceleration of the system. Solution. Two blocks weighing W1 and W2 are connected by an inextensible wire passing over a smooth pulley as shown in the figure. If W1 is greater than W2, the tension in the string can be calculated as T equals to W1 plus W2 minus 2mg, where m is the mass of the pulley and g is the acceleration due to gravity. Now, when the pulley is raised upwards with an acceleration equal to g, the tension in the string will be T equals W1 plus W2 minus 2mg. Since the pulley is smooth and frictionless, there will be no loss in kinetic energy and the system will accelerate upwards with a net acceleration of g. Therefore, the acceleration of the system is a g and the tension in the string is T equals to W1 plus W2 minus 2mg. So, the tension in the string is T equals W1 plus W2 minus 2mg. Thank you.